If you put Betelgeuse where the Sun is, it would extend to the orbit of Jupiter. The monster is completely unstable and will explode. It is one of the most well-known sources of radio energy throughout the whole universe. It's providing more energy than Betelgeuse or a billion suns. Betelgeuse is a red supergiant star. In the event that you put it in the Sun's direction, it would connect with the orbit of Jupiter Enormous. It's utterly unpredictable and also likely to explode. When we consider stars, most likely we envision them as small, luminous objects in the night sky. Basically, this is the way we see them, despite the fact that stars are something entirely different. Actually, one of the stars with the most acclaim, Betelgeuse, is significantly larger than the Sun. This star has caused confusion for a long time. Scientists, but something even greater and more upsetting has been happening with astronomers, and others who make Betelgeuse extremely well-educated individuals concerned. Watch this video with us as we investigate the wonderful information about Betelgeuse's imminent destruction. It's predicted by the James Webb Space Telescope, and how this new development came about will impact our universe and our lives, as explained by physicists here on Earth. Michio Kaku Betelgeuse is an enormous achievement. It's a significant star that has intrigued for such a long time. Astronomers, like Antonius, a Greek astronomer, was the first to realize that this star is a giant that can be seen in the night sky from Earth, especially during winter. If you're interested in cosmology, you have probably seen or heard of the star. The reddish-orange star marks the upper left shoulder of the constellation of Orion. So you can see that this star is old, quite possibly one of the most brilliant stars in the night sky. The thing about Betelgeuse's brightness is that it doesn't stay consistent. Rather, it changes, and this change is one of the excellent features of the star. But it isn't the only one. So, let's look into some of Betelgeuse's specific qualities. The majority of stars you see in the night sky are far from Earth. The nearest star is 4.2 light-years away from Earth. In the event that you do not recognize how the term light-years gives a perception of distance, see it this way. Consider moving at the speed of light for a whole year. It has been shown that light can travel 186,000 miles per second, the speed at which light can travel. If a year is equivalent to 1 light-year, and you crunch the numbers, you'll get billions of miles. So when we say the closest star is 4.2 light-years away, this indicates that it is very far away. Consider these few stars now. Earth is a great deal further away, and Betelgeuse, one of them, can be found around 600 light-years from Earth. So, if you somehow were able to get there, it would take 600 years. We can't move that quickly. Not even our quickest spacecraft can yet. Even now, this star can shine so brightly in our sky. If you're curious about how Betelgeuse can be so bright despite its distance, it's because of its singular qualities. Like size and luminosity, Betelgeuse is multiple times greater. Its estimated radius is greater than our Sun's, on the order of 1,000 times that of the Sun's tragic appearance as a disk in space when using modern telescopes, while various stars appear as small points of light. This is thought to be a result of the outside reactions in terms of its atmosphere's layers. Betelgeuse, in its entirety, averages 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equivalent to 2 by 1,030 kilograms of power. Scientists can't determine the specific mass of Betelgeuse due to the absence of other planets that revolve around it to compare it to. And naturally, we cannot directly measure it from this point on Earth. On the other hand, Betelgeuse produces at least 12 times as heavy as our Sun. Betelgeuse's brightness varies from magnitude +0 to +1.6. In simpler terms, Betelgeuse is many times more luminous than our Sun, so it must have been known as a red giant. But Betelgeuse's brightness does not last constant. It fluctuates. This change is due to its Betelgeuse-like pulsations. Expands, becomes brighter, then dims. And this cycle can last between 10 and 100 days, or even significantly longer. A unique property of Betelgeuse is that its surface area is covered in dark magnetic spots. The magnetic field here is far stronger than at the typical surface, however. The drawback is that these powerful magnetic spots interfere with the flow of hot gas to the outer surface of the star, creating The fact that these regions have a cooler star, there are so many of these spots in Betelgeuse compared to our Sun, which helps explain why, despite its size and brightness, it is cooler. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and significantly more numerous. To provide you with an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is 10 times stronger than that of the Sun. This field is why, when viewed through a telescope, the gases in the outer layer of Betelgeuse appear to be in circles or curves. Betelgeuse has a surface temperature of around 3,500 K. This low temperature contributes to the weak energy radiated by the star and its signature red hue. Betelgeuse is a red star, but it wasn't always red. Around 10 million years ago, it was yellowish, much like our Sun. Over time, the color began to turn orange-red, and then around 100,000 years ago, it gradually began to change into the red star as we now know. This has led scientists to believe that the star is maturing. Betelgeuse produces as much as 100,000 times more energy than the Sun. It would have been a formidable rival to our Sun if it weren't so far away. The fact that Betelgeuse is 600 light-years away means that with the unobstructed eye at night, it is quite visible. Only 8.3 light-minutes away from the Sun, which is why it is so powerful. If only Betelgeuse were a little bit closer, we would also be able to see it in daylight. But if it were to replace the Sun, it would eat or displace Earth and the other 4 planets close by because of its enormous size. In addition, even if it were to match the Sun's size, it would still produce more radiation. Betelgeuse, also known as Betelgeuse, is a very giant star located in the 600 light-year-old Orion constellation, years away from the planet. Its size is one of its most striking features, a multiple of our Sun's size in terms of distance. And it would easily encompass Jupiter's orbit if placed at the central point of our solar system. Betelgeuse's legendary size allows it to appear as a disk instead of a point of light when viewed through powerful telescopes, unlike most other stars. Despite its size, Betelgeuse is not the most massive star. Its mass ranges from approximately 12 to 19 times more than the Sun. The cause of this variation in mass estimates is the challenges in precisely measuring the majority of stars without companion stars or other objects to provide gravitational reference points. Still, even though its estimated mass is lower, Betelgeuse is a significant celestial body. Betelgeuse's brightness is another important quality that changes is its brightness over time, ranging in magnitude from 0 to plus 1.6. Compared to a star of magnitude 0, it is 2.5 times brighter than an additional magnitude. Betelgeuse, one star at its brightest, can be as bright as 1,000 times more. This fluctuation is the result of its periodic expansions, pulsations, and spasms brought on by the star's internal processes. When Betelgeuse expands, its brightness increases. When it contracts, it dims. These pulsations can last for months, which contributes to its vivacious display in the night sky. The surface temperature of Betelgeuse is relatively low for a star of this size, approximately 3,500 Kelvin. This provides it a distinct red color, typical of red giant stars that are about to reach the end of their lifespans. Like other red giants, Betelgeuse is approaching the end of stellar evolution. It has depleted the hydrogen fuel at its core and is beginning to combine heavier substances. This fusion process generates energy and causes the star to spread outward. Its atmosphere is rich in complex physical phenomena, showing dark magnetic locations on its surface where the field outperforms the surrounding area, areas where convection is prevented by these spots of heat moving to cooler parts. Despite these cooler spots, the surface of Betelgeuse continues to be very vigorous. But it will eventually meet its end in a spectacular supernova. Betelgeuse is an enormous star nearing the end of its existence, and its eventual fate will be a dramatic one. When it runs out of fuel, it will go through a severe process of transforming heavier elements into carbon and helium. This will result in the star possibly reaching a much greater size, making it one of the biggest stars in the night sky before it dies in a catastrophic blast caused by a cosmic explosion that signifies the passing of a huge star. The power of a supernova is strong enough to briefly surpass an entire galaxy. This phenomenon may or may not send shock waves through space. And it's possible Betelgeuse will undergo such an explosive end to its fate soon, although not immediately. There is something scientists are carefully studying, hoping to learn more about stars' futures and the universe's development. The excellent run of Betelgeuse is coming to an end. Astronomers are paying close attention to its behavior. The star is anticipated to eventually explode in an event that will result in the ejection of its outer layers into space, leaving behind an extremely dense core. This core could either collapse into a neutron star or further into a black hole, depending on its mass. A supernova is a cataclysmic event in a star's life cycle, signaling the final stages of its evolution. The eventual supernova of Betelgeuse may be visible from Earth without the aid of a telescope. Given its immense brightness and relative proximity, this explosion would produce a lot of energy, forming heavy substances like iron and nickel, which are necessary for the creation of planets and other heavenly bodies. These substances would disperse into the interstellar medium, enriching it and contributing to the formation of future generations of stars and planets. Interestingly, scientists have been able to detect Betelgeuse's strange brightness fluctuations. There has been speculation that the star is on the brink of a supernova. However, despite these variations, it is hard to predict exactly when the star will explode. According to some research, Betelgeuse could go supernova within the next 100,000 years, a short span on a cosmic scale, but still a great distance away. Precisely. The James Webb Space Telescope, JWST, has provided fresh perspectives on the star's behavior. Its infrared capabilities allow researchers to investigate the star's outer layers and magnetic fields in unprecedented detail. The JWST findings have helped confirm the star's changes, irregular brightness, and possible instability. Observations provide useful information regarding the processes that lead to a star's end. Offering a deeper understanding of stellar evolution, Betelgeuse's death will have far-reaching implications for the universe. The supernova's shockwave could potentially trigger the formation of new stars in the area around it, furthering the cycle of stellar birth and death. Additionally, the elements produced by the explosion will spread throughout space, contributing to the building blocks of new worlds in the grand scheme of cosmic evolution. The death of Betelgeuse will not only mark the end of one of the most massive stars we can observe, but also pave the way for the next generation of celestial objects. Despite the fact that we won't be in attendance, the study of the final moments of Betelgeuse provides valuable insights into stars, life cycles, and the universe's dynamic nature. The results of this star's research assist astronomers in gaining a deeper comprehension of the processes that govern the birth, life, and death of stars. It offers a glimpse into the fate of other stars that share similar traits that scientists of the future will look for. We hope to keep observing Betelgeuse with the assistance of cutting-edge technology and space observatory data. The star will continue to shape our understanding of astrophysics. What do such deaths mean for the entire universe? Betelgeuse, as a huge and active star, is an essential component of the cosmos. One of the reasons for its eventual demise is also what makes it one of the galaxy's most fascinating phenomena. While Betelgeuse's death is inevitable, it's critical to remember that the universe is constantly changing, and new stars are emerging from the ashes every moment. The energy released by a supernova like Betelgeuse's will ensure that the cycle of life and death in the cosmos continues. The legacy of Betelgeuse will live on, not just in the elements it produces, but also in the knowledge it has given 2 generations of astronomers and stargazers. As we continue to learn about stars like Betelgeuse, we unravel the mysteries of our universe, better understanding the forces at play and our place within them. From these giants of space, we gain knowledge and are reminded of the vastness and complexity of space, of the processes that inspire wonder and shape the universe we call home.